Good afternoon. You're welcome to today's class. Today we look at physics. Where did we stop in our last class? Huh?
Types of motion.
What was the last one we treated?
The oscillatory motion.
Oscillating motion, right? Okay. So today we look at relative motion. We look at relative motion. Oh yeah, put down. Relative motion refers to the motion of an object. Relative motion refers to the motion of an object observed from a particular reference frame or perspective. Observed from a particular reference frame or perspective. Reference frame or perspective. Or perspective is the motion of an object as observed from a particular reference frame or perspective. Full stop. Continue. It is a fundamental concept in physics. It is a fundamental concept in physics. It is a fundamental concept in physics that describes how the motion of an object, that describes how the motion of an object, appears to change depending on the observer's frame of reference. Then frame. Look at the board. Frame. Reference. Depending on the observer's frame of reference. Paragraph. In other words, relative motion, relative motion is the motion of an object. Relative motion is the motion of an object relative to a specific observer. Or reference point. I said that in other words, relative motion is the motion of an object relative to a specific observer or reference point. Full stop. Continue. It is a measure of how the object, of how the object's position, velocity, and acceleration appears to change from the observer's perspective. appears to change from the observer's perspective. Appears to change from the observer's perspective. Is that clear? Now, you may stand here, or you may be in a vehicle, and the vehicle is moving. You may be in a vehicle, and the vehicle is moving. Maybe there are trees. If you're in that vehicle, you think those trees are moving. True of us. Have you ever noticed that? Or maybe a tree is here, standing here, and you're in a vehicle, and the vehicle passes. You will think that the tree is the one that moved like this. Yes, you will think that. But you are the one that is actually was moving. Now, the motion between that vehicle you are in, you in that vehicle, and that tree is what is called what? Relative what? Motion. Relative what? Motion. So, relative motion, you are comparing motion between two objects. It's not like the type of motion we described before. That is what we just one object moving. This one now, you are comparing movement between two objects. And how the movement will look like depends on the frame of reference. If you are in vehicle, and you will think that vehicle you are in, unless there's gallop, you will think the vehicle is not moving. If you're in vehicle, you're not looking at. You will think that the vehicle is not moving. Do you know why? It's because you are moving with the same velocity with the vehicle. So the relative speed between two of you is 0. You will not feel it. You will not know that the vehicle is moving. Because you are moving, you are in that vehicle, you are moving with the same speed with the vehicle. Because the vehicle is carrying you now. Is that clear? So you are moving with the same speed with what? Vehicle. And in the same what? Direction. Am I communicating? That's why you will not feel. You not feel that the vehicle is moving. But the moment you stand up and start moving inside the vehicle, that's when you know that the vehicle is actually what? Moving. Am I communicating? Maybe the vehicle is moving like this, and you are in it. The relative velocity between you and that vehicle is 0. That's why you don't feel it. But once you start moving like this, you start moving like this, moving ahead in the same direction with the vehicle. You remember, you can move like this, and you can also move back. Hope you know. Are you aware? Now, when you move like this and move like that, the relative speed of velocity between you and the vehicle will change. Now, the same thing now, if you are in a vehicle and you are looking at the vehicle in front of you moving, and your vehicle is pursuing that vehicle moving in this direction, the relative speed between you and between your vehicle and that vehicle that is in the front, the relative speed between two of you is the addition of, is the subtraction of the speed with which that vehicle is moving and the speed with which your own vehicle is what? Moving. You don't understand this, right? Don't worry. Just listen carefully. It's simple. It's not something difficult. That's what we call what? Relative motion. The basic thing you should understand is that relative motion studies the difference between the velocity with which a body is moving and which another body is what? Moving. You are comparing two of them now. So when you hear relative speed, you are comparing the speed between with which the two vehicles or two objects are moving. That's why I say that when a vehicle passes this gen now, this gen is one place, this gen is not moving. The vehicle is moving at its own speed, but you will think that the gen is moving because you are the one moving. You will start thinking that the gen is moving, but the gen is one place. Huh? But the gen did not move. It's you that is moving. Now, that motion between you that going like this and that gen is what's called what? Relative what? Motion. From the point of reference now is you in that vehicle is the point of reference. There can also be point of reference. Maybe you are standing here and the vehicle moves like this. You become point of what? Reference of the motion between you standing and the vehicle or train moving. Now, there are some examples, there are some aspects, things I want us to understand, things that we need to really touch for you to understand this relative motion. So we call them key aspects of relative motion. 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 Number one. One is dependence on reference frame. Dependence on reference frame. Dependence on reference frame. Dependence on reference frame. Relative motion depends on the observer's under dependent. We are saying that it depends on the reference frame. That's the point I'm trying to make here. Then relative motion depends on the observer's reference frame. 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 You can call it reference frame or reference points. That is from where the observer is observing the what? The movement. Is that clear? Then continue. The same object, continue. The same object can appear to be moving. The same object can appear to be moving differently. The same object can appear to be moving differently to different observers. The same object can appear to be moving differently to different what? Observers. Let me explain. Answer me this question. This journey is here and I'm driving. You are in my car and you're looking at through the other side of the vehicle. And I'm driving in this direction. I'm driving in this direction and you are observing this thing, this journey. Then you are now in my vehicle now. I'm driving back and you are observing this journey. I'll drive like this. Now tell me, if that time I am moving like this, from your own point of frame, reference frame, you are looking at this gen, which direction would this gen appear to be moving? That is shape, because I'm driving like this, right? Now, when I'm not driving like that, which direction do you dating the? But the jet is not moving. No. But if I ask two of you, you will say this jet was moving like this. You say the jet was moving what? Like that. That's what this dependence, this point I raised now is trying to me is explain. That how you view the motion depend on the what? The reference what? Frame. The direction will depend on the what? The reference what? Frame. Is that clear? Is that clear? Of course, do you know why it appears as if this jet is moving? Do you know why? Because there's a difference in the velocity. There's a difference in the velocity of the car and the velocity of this jet. Velocity of this jet is what? Is what? 0. We are moving with maybe 20 meters per second. There is a difference between the velocity of the. There's a difference. 20 minus 0 is what? 20. So there's a difference between the velocity with which this jet is moving and my velocity. That's why it's 20 what? That's why it looks as if the jet is what? Moving like this. But even the jet is also moving at the same 20 meters per second. I will not feel that I will not even notice that the jet is moving. I didn't the jet is so moving at the same speed with me. If you are in a car, if you are in a car, two of you are like this, and you're moving at the same speed, you will notice, unless you see the tire moving, you won't feel that the vehicle is moving. If two of you are moving at the same speed, in the same direction, you won't feel that this vehicle is what? Moving. Is that clear? Is that clear? The next one is motion. Number 2 points. Now 2 aspects. The second aspect I want us to look at. Motion is relative. Motion is relative. Motion is relative. Then put colon, continue. There is no absolute motion. There is no absolute motion. Full stop. Motion is always relative to a specific reference frame. Motion is always relative. Motion is always relative to a specific reference frame. Motion is always relative to a specific reference frame. So what that to say that there's no motion that is absolute. Do you understand what you mean by saying that something is absolute? Let's assume that you have, as you are now, you are dark with compression, right? If I'm just talking about you are dark in compression, right? But the moment I start comparing you with that is absolute, you are dark. Absolute, it is an absolute term, you are dark. But once I start comparing it to you with me, he is fair, right? It's fair, right? If you just have it, maybe you are the only that person, let me use this to. He is fair. If you are not seeing this person, you are looking at him. He's fair. True of us. He's fair. Absolutely, he's fair, right? That's absolute. But the moment you bring her in now, we will see question of fair again. Yeah, this one is fair. You start seeing it as what? Dark. True of us. Relatively, absolutely is fair. But relatively, he's not fair. He's what? Dark. Darker. True of us. He's say relatively, you are comparing. When you say absolute, it's only that thing. So we are saying that there is no motion that is what? Absolute. There must be a comparison from a reference point. If I start a motion, let's assume now, I start my motion from this board. This board becomes my reference point. If I travel like 6 cm, sorry, look up. I started my motion here, right? And move to this point. Before you can say talk about the distance I have traveled, you must bring in the reference point. From which reference point? If the reference point is from this board, it can be 50 cm. Is that clear? You must mention reference point. You cannot just say I have traveled 50 cm. From where? You know from where? Three of us. If I say I traveled 100 meters, the next question will be from what? From where? You want to know where that started from? That's the reference point. Is that clear? So that what we say that no motion is what? Absolute. There must be a reference point or reference frame. If I say, okay, the reference point can be what is my distance, what the distance covered from this point. You now check it, two of us. You cannot talk of the distance I covered without mentioning from where you start doing the work, the measurement. Is that clear? So that's what we want to mean by saying that no motion is what? Absolute. Okay. The next aspect is velocity. Velocity and acceleration are relative. Velocity and acceleration are relative. Velocity and the acceleration are relative. Velocity. Yes. Velocity and the acceleration are relative. Velocity and acceleration are relative. All right. The velocity, are you okay? The velocity and the acceleration of an object. The velocity and the acceleration of an object are also relative to the observer's reference frame. The velocity and acceleration of an object are also relative to the observer's reference frame. So apart from the distance I mentioned, even the velocity and acceleration are also what? Relative to where the what? Observer is observing the motion from. Reference frame. You remember before I used distance first. I'm trying to point out that even velocity and acceleration are also relative to what? Observer's reference frame. You cannot say that the vehicle is traveling at a speed of so you must talk about where the motion starts from, or what is the reference point of the velocity. Let's assume I'm here now. As I told you, let's assume I'm here and I observe a vehicle. Let's assume I'm here and I observe a vehicle move like this. Exactly. I observe a vehicle move like this. What is my own velocity? 0, and the vehicle is moving like this. The relative velocity between me and that vehicle is the velocity of that vehicle minus what? My own velocity, which is what? 0. So the vehicle will actually be moving at what? If the vehicle is moving at 20 meter per second or kilometer per hour, as case may be, and me are not moving, actually the velocity of that car from my own reference point is what? 20 kilometer per hour. But let's assume the vehicle is moving like this, and I'm moving too in the same direction. The vehicle is moving like this, and me, I am moving in the same what? Direction. I am moving in the same direction. The relative velocity between me and that vehicle, maybe the vehicle is moving at 20 kilometer per hour. Me, I'm moving at 5, let's say 1 kilometer per hour. Let's assume, even though I know it will be much, but let me just fix any value. I'm not measuring the accurate measurement. Let them just fix any value. The vehicle is moving at 20 kilometer per hour in this direction, and me, I am moving in the same direction with the velocity of what? 1 kilometer per hour, for example. Now, the relative velocity between me and that vehicle will be the velocity with which the minus my own what? Minus my own what? Velocity. That is 19 kilometer per hour. That will be the what? The relative velocity between me and that vehicle. But let's assume the vehicle is moving like this. Me are moving like this. 20 km per hour. Me are moving with 1 km per hour. The velocity, I will see that vehicle moving at 21 km per hour. Because me, I am also moving with 1 kilometer. Going like this. He moving with 20 km going like this. I will see it as 21 km per hour. That the vehicle is moving at what? 21 km per hour. Those in the vehicle will see me moving at what? 21 km per hour. Am I complicating? Am I complicating? Yes. The same thing also happens with acceleration. So let's look at examples of relative motion. Let's look at examples of relative motion. Examples of relative motion. Number 1, train and platform. Train and platform. Train and platform. Train as in train. Train and platform. A person on a train platform. When I say under that train, you know what a platform is, right?
Yes.
That place where passengers wait and train passengers. A person on a train platform. A person on a train platform. A person on a train platform observes a train moving at 50 km per hour. A person on a train platform observes a train moving at 50 km per hour. Full stop. I am on a train platform. Me, I'm standing, and I can observe a train moving at 50 km per hour. Is that clear? Like this. Continue. However, a passenger on the train A passenger on the train, a passenger on the train observes, a passenger on the train observes the platform, observes the platform, observe the platform moving at 50 km per hour in the opposite direction. You said to me what I explained about it there. I am here on the platform. I will see a train moving like this. You are 50 km per hour. Then somebody in that train, in this direction, somebody in that train that is moving will see me moving like this with the same speed. Is that clear? Another one, the second example. Number 2. Car and the pedestrian. Car and the pedestrian. You know who a pedestrian is? Car and the pedestrian. A pedestrian observes a car. A pedestrian observes a car. A pedestrian observes a car. A pedestrian observes a car moving at 60 km per hour. A pedestrian observes a car. A pedestrian observes a car moving at 60 km per hour. Full stop. However, the driver of the car observes the pedestrian moving at 60 km per hour in the opposite direction. The same thing. However, the driver of the car observes the pedestrian moving at 60 km per hour in the opposite direction. However, the driver of the car observes the pedestrian moving at 60 km per hour in the opposite direction. Is that clear? Is that clear? Same thing. I am driving a vehicle and you are here. You are walking or you are standing somewhere. You see my car moving at what? You saw my car moving at 60 km per hour like this. Me that is driving like this, we see you moving like this at the same 60 km per hour. Number 3, another example. Astronaut and the Earth. Astronaut and the Earth. You know who an astronaut is, right? Good. Those in space, right? Astronaut and the what? The Earth. An astronaut in space. An astronaut in space. An astronaut in space observes the Earth moving beneath them. An astronaut in space. An astronaut in space. An astronaut in space observes the Earth moving beneath them. An astronaut in space observes the Earth moving beneath them. However, an observer on Earth An observer on Earth observes the astronauts moving through space. An observer on Earth observes the astronauts moving through what? Space. Is that clear? Is that clear? The astronauts on top, in space, we observe what? We observe what? The Earth moving beneath them. Whereas those on Earth will observe the astronaut just wandering in the what? In the space. Is that clear? Now let's do some calculations on this relative motion. Let's do calculations. Alright, example 1. Take down the question. In fact, I'll give you two minutes to solve the question. Let me know whether you truly understood what you've been saying since. Question 1 says, a car traveling north. A car traveling north 60 km/h. So a car is traveling. Please put is. A car is traveling. A car is traveling north. A car is traveling north, please. A car is traveling north at 60 km/h, comma, while a pedestrian is walking south. While a pedestrian is walking south at 5 km/h. Sorry. While a pedestrian is walking south at 5 km/h. Full stop. What is the relative speed? What is the relative speed between the car and the pedestrian? What is the relative speed between the car and the pedestrian? What is the relative speed between the car and the pedestrian? I try it. I give you 2 minutes to. I give you two minutes to attempt it. I give you two minutes to attempt the question. What's the answer? I'm waiting. What's the answer? Huh? How do you get 65 km/h?
Because the car is walking south, north, then the pedestrian is walking south.
Okay.
So that they are walking opposites.
Okay.
So that's the relative speed will be the. I don't know how to explain it, but because since the car is walking in another place and the pedestrian is walking south,
Okay.
it will be plus because the pedestrian has the own speed which is 5 kilometers and the car has the own 60 kilometers. So if you have both of them,
You know what I'm saying? Because he's moving like this, so he's moving like this. You see, it has its own speed. I don't think it has its own. So the relative speed between two of them will be this. The one with which it was going plus one with which this one was going, making it what 65 kilometers per hour. Is that clear? Is that clear?
Yes.
Did you understand it? Are you sure? Okay. I like that. That means you are following. That shows you are following. That's good. I like that. Okay. Let me
I
look
think they are
at
going in the same direction.
it's just yeah. Yeah. Second question. So you solved it now, right?
Yes.
Second question. Two boats. Two boats are moving in a river. Two boats are moving in a river. Full stop. Boat A is traveling upstream at 15 kilometers per hour. Boat A is traveling upstream. Upstream. Boat A is traveling upstream at 20 kilometers per hour. So, sorry, 15 kilometers per hour. Sorry, 15, yes, comma. While boat B is traveling downstream. While boat B is traveling downstream at 20 kilometers per hour. Full stop. The speed of the river current. The speed of the river current is 5 kilometers per hour.
What?
Huh? The speed of the river current. The speed of the river current is 5 kilometers per hour. Full stop. What is the relative speed between the two boats? What is the relative speed between the two boats? What is the relative speed between the two boats? Who can solve it? Who get mine? Try it. Let's see. You say what? What did you say? Huh? I didn't get you. What did you say?
Oh, I don't know this one.
Try. It's simple. Just try.
What is then divided minus, like what the upstream
Current
and
is affecting both.
Huh?
The current is affecting both of them.
Mm.
So the current is moving. That is moving. Oh, I don't know. But if the current is not there, it will be simple. But that current. The current moving. I don't know. So I think the current
Before you can answer this question, you should know what is upstream and downstream first.
yes.
So
What
what
is the upstream and the downstream?
the upstream
is what?
meaning the upstream, meaning the boat is
What do you understand by upstream of a river and downstream of a river? What do you understand by that?
the upstream of like the boat.
Where does the water flow? Does it flow from downstream to upstream, or does it flow from upstream to downstream?
Flow from upstream to downstream.
Confirm. Now, what of current? What do you understand by current?
Current flow from upstream to
What direction does current flow?
current flow is the same as upstream.
Is it always like that?
Sometimes it's
Current can flow it must not be for, but we know that it should flow for, but sometimes it can go opposite. Sometimes you can have opposite currents. Hope you know. Hope you know. So that current can go like this. It mustn't be from upstream to downstream. So, but the question now, the question did not tell us the particular direction for the current.
Yes.
He just said, so we can solve this question in two ways. We can look at the question, we can solve the question when the current is going from upstream to downstream and see what the answer we'll get. We also solve it when the current is going from downstream and see what the answer will. You know, when the current, which of them do you think can cause turbulence?
Like both of the ship.
Well, I mean, in terms of the current, in terms of the which of the direction of current can cause waves or
Okay.
turbulence.
If the current, like any of the direction, if the current is coming down to the downstream, it can be normal. But if it's going up there, if it's returning, of course.
Good. You begin to understand this now, right? Now, so let's do this. They didn't tell us about turbulence now, two of us. So let us assume that it's moving downstream. Let's assume, because everything is peaceful. They didn't say anything about. Let's just assume that it's coming what? It's moving what? Downstream. Good. Now, we can still solve both of them and see what to give up. But let's solve the one for that as moving down up to downstream first and see what the answer we'll get. Now, let's solve it. It's clear that you cannot solve this one. Or will you try?
Okay, you have explained it. Let us try. Let me try.
Okay, let me explain. So you can try. Now we have already known that you know that. Let me sketch it on the board. I would have preferred black marker to this. At least black stands out. You understand? You know what I'm saying? Now, either black or red is okay. You cannot overshadow them. Especially black. Now, this is the upstream, right? Let's take this at the upstream. The river is flowing down, right? This is upstream, right? And this is what? Downward stream. The question says two boats are moving in a river. Boat A is moving upstream at 15 km per hour. This is boat A. Boat A is moving upstream at what? 15 km per hour. Then while boat B is moving down, traveling downstream at 20 km per hour. Boat B is moving like this, right? Boat what? This is B, right? B at what? 20 km per hour. Boat B is moving, traveling downstream at 20 km per hour. Boat A is traveling upstream at what?
15 km per hour.
This boat A may enter trouble. Hope you know. Are you aware? Are you aware? But let's go. They didn't say what happened to them, so let's continue our work. Now, look up. The speed of the river current is 5 km per hour. Now, the speed of the river current, let's assume it's moving from downstream, right? So river current is moving like this, right? 5 km what? Hour. They want us to know. They don't know the relative speed between the two boats. The direction. There is a relative motion. You solve internally before you come out externally. There is a relative motion between the river current and each of the boats first. So you find the relative speed between the current at both A and keep it. Then find the relative speed between the current and both B and keep it. You now find the relative speed between the two speed you get and
that makes since the back current is coming backward and this one is going forward, so automatically this 15 has reduced to 10.
Both A is moving up, right?
Yes, and the back current is coming up.
Yes.
So it has reduced to 10.
It's 10.
And it has increased now 1 by 5.
This one is now what?
Increased to 5. That's
They are in the opposite direction,
no.
Check well, no?
That one is going upstream.
Check this one well.
Both B.
Start from both A.
That one is traveling upstream. It's going up. This one is traveling downstream. That's going down. So it's coming from where the wave is. So the wave is supporting this other wave.
This one.
No,
Both A is what?
Both A is 15. Is traveling upstream.
Okay.
That's the wave is coming downstream. The wave is
So,
coming downstream. That's the shore of the river.
What is the relative speed between both A and the current?
That's 10.
Is it 10?
Yes.
How is it 10? Check. Sorry.
Sir, according to the other
Is it 10?
See, I'm talking about this. You said the boat A is traveling upstream. That is going up the stream. That is exactly. So you said we should use the normal way that current flow, which is out coming out.
Yes.
So since this one is going and the boat is coming, that 5 kilometers that is going to come outside from the shore, it will be reducing.
You are using vector formula to solve this thing. This is the same thing as I am going like this, you are going like this. What is the relationship between the two of them?
Okay.
What are you saying? This one is going like this. Okay. What is the relationship between the two of them?
20.
It's 20 now. This is not 20. This one is going 15. This one is going what? 20.
How about that downstream? The downstream.
They're asking you the effective or whatever, or what is it called, the vector. They're asking you what is the relative speed between the two of them. This is 15, 5 is 20. This one is and this one are in the same direction.
Okay.
This is 20 minus 15, which is what? 5, which is what? 15.
Okay.
So this one here now, here, this one is what? 20, right?
Yes. And this one is
So what? Are you following?
yes.
15.
Not 30.
But both A is going like this.
Yes.
Both B is going like this. So 20 plus 15, 35 kilometers per hour.
That's the answer.
That answer.
That's the answer.
What's that?
No, I'm not solving. I'm asking that's the answer.
Are you sure? Are you sure?
Yes.
Okay, let's look at a situation whereby the current is the water current is up.
Okay, it's going up.
Let's see what we get. Here, water current is now what? Up, right?
Yes.
So let's see what we get. Here is what?
5
So let's see what we get. If the water current is up,
Now one.
that is now in the same direction with what? A.
Yes.
So
Is this on
It's 10.
it's 10. Here becomes what? 10.
It's on that.
Here becomes what?
So it's 5.
Here becomes what? 25. 25, right?
Yes.
Add two of them. 35. The same thing. Is that clear? Is that clear? It's simple, actually.
We got it for that explanation.
We have just roughly 5. Let me see what I can get past question.
I don't know it past question.
I didn't. You don't have it. Official, I don't have. No, we have jam past question. Don't have. I wanted to see if you can. We are just 5 minutes to go. I wanted to see if you can get question on this topic and solve from past questions.
Eniola, someone is looking for you outside.
So there's no way we can get past questions. And those people here, they're not doing physics. There's this commercial lady that was doing that but okay, she did better with us. Okay, it's true. Okay, let's continue now. Maybe next time, let's continue. Let's move to the next subtopic. Maybe next time we can look for past question. No, I'm working based on the time I started the class. 1 hour from the time I started the class. That's why I check my own time.
Yeah, I didn't hear by
Because you teach you for another 1 hour.
When do you want to leave here? By 4? By 2?
now.
Okay, is it 2 you close?
Yes, that's why I say you can take things from the remaining.
Okay, is it 2 you close?
Yeah.
So if you go now, what we are going to now? Calm down.
Me here.
Okay, let's look at collinear motion. Collinear motion. Collinear motion. No, just a subtopic on its own. Collinear motion. Just write collinear motion as. Are we together? Collinear motion refers to the motion. Collinear motion refers to the motion of two or more objects. Collinear motion refers to the motion of two or more objects along the same straight line. Collinear motion refers to the motion of two or more objects along the same straight line. Full stop. Along the same straight line. Along the same straight line. Full stop. In other words, comma. In other words, comma. The objects are moving in the same direction. In other words, comma. The objects are moving in the same direction. Either towards each other, or away or away from each other. Either towards each other or away from each other, but always along the same line. But always along the same line. We have spent 1 hour now, so let's stop. In our next class, we'll continue from where we stop. Okay? Okay? Yes, I don't know. So if you go now, you can study more on that. In our next class, we'll continue from where we stop. All right, thank you very much. See you next time.